Okay, I don't have the original diagram posted on this board, but I have a sketch that's pretty similar. The letters are the same. In the problem presented, this angle right here was given to be angle alpha instead of 60 degrees, but it's a little easier to see if you use 60 degrees. So I'll do that. And then later we can replace this with alpha and see what happens. So we start with triangle ABC, which is a right triangle with vertex at A. And then we drop this perpendicular or altitude from the right angle perpendicular to the hypotenuse and intersecting the hypotenuse of the big triangle at D. And you're asked to prove some similar triangles and then make some deductions about corresponding sides. The key is that if this angle right here is 60 degrees, then this angle right here in triangle ABD is 30 degrees. They have to be complementary. If this was alpha, you'd label this 90 minus alpha. And by the same token, if this is 60 in the big triangle, angle C has to be 30, complementary. So this would be 90 minus alpha. This would be alpha. And so we have three 30, 60, 90 triangles. Triangle 1 and triangle 2 are the little triangles. And the big triangle is also at 30, 60. So all three triangles are similar to each other. So let's say you start with triangle ABD and you'd like to figure out how to name triangle 2 correctly. In triangle ABD, angle A is 30 degrees. And triangle 2, it's A corresponds to C because it's 30. That's why I have a C here. And then if I'm in triangle ABD, B is 60. So I have to go this way in triangle 2. That's why it's CA. And angle D is 90 degrees in both triangles. In a similar fashion, if you wanted to get ABD similar to the big triangle, you'd pay attention to this A is 30 degrees. That's angle C in the big triangle. B is 60. That is B in the big triangle. And A corresponds to the 30-degree angle. CBA. Okay. I'm not sure I got that right. CA is 30. The big triangle 30 is C. AB. Yeah. B is 60 in both triangles. Okay. Now, if the triangles are similar, let's use this right here so you can see the idea. AB corresponds to CA. AD corresponds to CD. And BD corresponds to AD. And let's use the letters that are on the diagram. AB is C. CA is B. AD is H. CD is A sub 2. BE is A sub 1. And AD. So by setting this up, you could say that H is the mean proportional. This altitude is the mean proportional between the pieces of the hypotenuse of the big triangle, or H squared equals A sub 1 times A sub 2. Now, that wasn't one of the questions you were asked. If you use these two triangles, you'd end up with a different set of three ratios being equal. And you could deduce that A sub 1, C is the mean proportional between the entire hypotenuse, which is A, and its projection on the hypotenuse. So that gives you C squared equals A times A sub 1. So A sub 1, I'm not writing very well, A sub 1 equals C squared over A. And you could do a similar thing for B. B will be the mean proportional between A and A sub 2, and you could solve for A sub 2. Okay, there you go. A little longer than I intended, but I hope that helps with your original problem.